So the next concept that we have is equation of chord whose midpoint is given. Whose midpoint is given. So we have a circle. The equation of circle is given as some s equal to 0 and AB is a chord. The midpoint of the chord is given as x1, y1. What will be the equation of the chord AB? So in this case, the formula is S1 equal to S11. Is S1 equal to S11 is the formula for equation of the chord when the midpoint is given. Like for example, if the circle S is x square plus y square minus r square and s equal to 0 refers to this circle. What is the s equal to 0 circle? X square plus y square equal to r square. So what does S1 represent? Xx1 plus y1 minus r square is S1 equal to S11 will be x1 square plus y1 square minus r square. So you can cancel this on both sides and the resulting value will be the equation of the chord when midpoint is given. So we can straight away remember this formula and use it in the problems. So I'm not doing the derivation for this. But even if they give a different circle with a different center also, S1 equal to S11 is still valid. The values of S1 and S11 will be written according to this S. So if the circle is changed, you can change S1, S11 according to that. But formula would be the same, S1 equal to S11 only. Then we write down length of chord whose midpoint is given. So if x1, y1 is the midpoint of the chord and the circle is S equal to 0, what will be the length of this chord? So directly what we can do, join A and B with the center. This will be perpendicular. Suppose for convenience, I'll take center as origin, but the result we are deriving will be valid for all circles, even though I'm taking center origin and deriving it. So if the center is origin, the distance CM is nothing but under root of x1 square plus y1 square by distance formula. And CA is the radius which we already know. So by Pythagoras theorem, AM square will be equal to CA square minus CM square. So this is R square minus of x1 square plus y1 square because root is eliminated after squaring. So clearly if you take minus common, it is x1 square plus y1 square minus r square. So which is nothing but minus of s11. So this is AM square. So AM will be equal to root of minus of s11. And what will be AB? M is the midpoint. So AB will be 2 times of this. So 2 times root minus s11. But don't think that because of minus sign it is negative. Actually, whenever a point is inside the circle, I told s11 is negative. So x1 by 1 actually lies inside the circle. So whenever a point is inside the circle, s11 is negative. So minus s11 is therefore positive. So even though there is a negative, it doesn't mean it is root of imaginary or something. S11 is negative, so minus s11 is positive. So this is positive only. And just to avoid the confusion, you can put a modulus. 2 times root of mod s11. This is the formula to find out length of a chord when they give you the midpoint. We can straight away use this as a standard formula. And even though they change the circle, you can still use the same formula. But the value of s11 should be written according to the circle equation given here. Then related with midpoint, we have one last result. They'll give you for locus question. The locus of midpoints of chords of the circle with subtend. Equation of circle is our choice. We can take anything. With subtend a constant angle alpha at the vertex. With subtend a constant angle alpha at the center of the circle. So same diagram again. So if the chord is subtend an angle of alpha at the center, this is given. What is the locus of the midpoint? M, where you can take the circle as x square plus y square equal to say r square and derive. And later we'll write for other forms of circle with center HK and all. But let us do it with this. So given that the chord AB subtends alpha at the center, what is the locus of the midpoint? What is the locus of this? So for this, what we do, just again join these two. This will be perpendicular. And that angle will be divided into 2 equal parts, alpha by 2 each. Because they are congruent triangles. This is the radius r. So from the diagram, if I take this as say x1 comma y1, center as 0, 0 according to the circle given. So clearly in triangle AMC, what is cos alpha by 2 adjacent by hypotenuse, so CM by r. And the distance CM you can write by distance formula. So you'll get cos alpha by 2 equal to root of x1 square plus y1 square divided by r. This is the distance between these 2 points. Then cross multiply and square it. You will get x1 square plus y1 square is equal to r square cos square alpha by 2. So therefore, what is the locus of x1, y1? You have to just replace x1, y1 with xy. X square plus y square equal to r square cos square alpha by 2. So this is the locus of midpoints of the chords with subtend angle alpha at the center. This is for the case where center is origin. So if the circle is changed as x minus h whole square plus y minus k whole square equal to r square, then what would be the answer? You'll just have x and y replaced with x minus h and y minus k. Rest of it will be the same only. This is the locus of midpoints. If this is the circle given, the locus of midpoints of chords subtending an angle alpha at the center. So then after this we have tangents and normals. We just need to find their equations. So the first result is equation of tangent and normal in point form. So if you are given a circle equation as s equal to 0 and you are given a point on it as x1, y1. So if you are asked to find out the tangent equation, then the formula is s1 equal to 0 for that. So the tangent at px1, y1 to the circle s equal to 0 is s1 equal to 0. And we know how to write s1 if s is given. So this is the first result. And if you have to just derive it also, so just drop a perpendicular, you will be given the center. Suppose if I give you general circle for a change, minus g minus f is the center. Let the circle S be x square plus y square plus 2gx plus 2f5 plus c. Just for a change, I'm taking this circle. If this is the circle S equal to 0, so then if you have to find the tangent, what we should do? We have to just find the equation of the line through P and the slope should be known. Here you can find even without differentiation, but for other chapters like parabola and all, we need differentiation. So basically to get the tangent slope, find the derivative at P. So if you differentiate the curve, you'll get 2x plus 2y dy by dx plus for 2gx derivative is 2g. For 2f5 derivative is 2f dy by dx. For constant derivative is 0 equal to 0. So from here you'll get dy by dx value as minus of x plus g by y plus f. And since you need the tangent at this point, you find derivative at that point. So dy by dx at that point P. Means you just have to substitute the coordinates and write minus of x1 plus g by y1 plus f. So once you know the slope of the tangent, we'll use the symbol small m for the slope. What is the tangent at P x1, y1? The tangent at any point is given by point slope form. Y minus y1 equal to small m into x minus x1, where m is the slope of the tangent. So y minus y1 equal to what is m? Write this value minus of x1 plus g by y1 plus f into x minus x1. So if you actually cross multiply and simplify this result, this will give you s1 equal to, actually it will give you s1 equal to s11. And we'll write this as s1 equal to 0 because s11 equal to 0. Why s11 is 0? Because the point is on the circle. x1, y1 is on the circle. So s11 is 0 since P lies on the circle S equal to 0. s11 is 0. Implies s11 is 0. That is the reason when you actually simplify this equation, it will reduce to s1 equal to s11. Since s11 is 0, the equation becomes s1 equal to 0. And what is s1 for the general circle that I have chosen? xx1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. That is the meaning of s1 equal to 0 for general circle. And if it is a circle like x square plus y square equal to r square, the tangent would be just s1 equal to 0 again, but it is xx1 plus y1 minus r square equal to 0. And in case if the circle is x minus h whole square plus y minus k whole square equal to r square, the tangent would be just x minus h into x1 minus h plus y minus k into y1 minus k minus r square, because this is the value of s1 equal to 0. So this is the circle and this is the tangent at P, you can say. For the other circles, we derived it for general circle. For other two circles, you can write like this. So this calculation part I didn't show. This will simplify to this format. So I wrote that directly. So this is for tangent equation. If you have to find the normal equation, you just need to find equation of CP because the normal is along the radius only. You already know these 2 points, so just find equation of CP using 2-point form. So if you have to find the normal at P, is nothing but equation of CP, where C is minus G minus F and P is X1, Y1. So for these two, just apply 2-point form. Then you get Y minus Y1 equal to X minus X1 into what is the slope? Difference in Y coordinates Y1 plus F by difference in X coordinates X1 plus G. This is how you can write down the normal in general. So this is for the circle with center minus G minus F. And if it is the normal at P, X1, Y1 to the circle X square plus Y square equal to R square, then it is same as this. Only thing is my G and F are 0. So the formula would be Y minus Y1 equal to Y1 by X1 into X minus X1. When you cross multiply and simplify, two terms will cancel. It will actually give you XY1 minus X1y equal to 0. Because out of 4 terms, 2 will cancel. And similarly, if it is a normal at X1, Y1 to the circle with center at HK, that is, if you want normal at X1, Y1 to the standard circle X minus H whole square plus Y minus K whole square equal to R square. So you just have to find out equation of CP. So it will be Y minus K equal to X minus H into the slope. When you're finding, you wrote for these two, this will be HK in that case. So Y1 minus K by X1 minus H. This is the formula to find the normal equation. So here you don't need to by heart anything. When they say normal, you just apply 2-point form for the point P and the center. But for tangent, because it is short S1 equals 0, you can remember it. So this first form is the point form. There are 2 other forms like slope form and parametric form. So we'll discuss that.